In this example, we're going to use an array, but we're going to add a little bit more error checking to it. So what we want to do is just create something called a passcode validator. And it's going to be pretty simple. All we're going to do is check input from the user against a list of valid passcodes to see if it matches. And if it does, we'll authenticate the user, and if not, we won't. So probably not the best program. We're going to hard code the codes in here. So we're going to go ahead and declare the array code, and we'll initialize it using some values. So I'm just going to put in some random codes here, and so that'll initialize our array of codes. Our actual array name is code. Okay, so the codes are stored in the code array, and we'll go ahead and create a variable for the array size, the maximum array size, and that would be std : size of the code array. Now, since we used using namespace standard here, we really don't need std : here, so we can simplify that to size. Okay, and this is what we should use when dealing with arrays. Just in case we initialize this, we didn't specify the size here, so the size depends on how many inputs we put in. This kind of records that, and we should use that throughout our program when we're dealing with the array and the array size. Okay, so the other thing we're going to need to do is let the user input a value, so we're going to let them type in a security code. Okay, and we'll just initialize that to 0, and then we're going to want to check to see if it was valid at the end. So I'm just going to create a Boolean variable. Booleans hold true or false values, and I'm just going to say is valid is the name of that variable, and I'm going to go ahead and initialize it to false. Okay, that way we know we start out, assume it's wrong to begin with, and prove it is correct to get it done. Okay, so the next thing we're able to do is prompt the user for their security code. So we'll see out, please enter your security code, and then we'll see in the variable we declared, security code. That way they've entered that. And then we'll run through the array to see if what they entered matches anything in the array of codes. So we're going to start out for declare an integer I from 0 and stop when we get to 9. We can look to see if that's correct or not. Now, I'm intentionally doing this the wrong way. What we should put in here is what? That maximum array size. Okay, but let's leave it there for now, and then we're going to increment by 1 going through the array. And then we need to check each one. Okay, if the security code is equal to that code, okay, so code sub 0 all the way up, then we have an invalid assumption here. Boolean value is valid is not false, it's actually true, so we'll set it to true. Okay, and so we'll check at the end of that loop. So the loop ends here. We're going to check to see if is valid, and if so, we're going to see out access granted. That means the code was true. Otherwise, we're going to say access denied. Okay, and this is actually a Boolean value, so we don't have to compare it to say if is valid equal true. It's a Boolean value, so it already evaluates to true or false. So let's run this and see how it works. Okay, so we'll enter our security code. I'm just going to 1, 2, 3, 4, 5, 6, and it tells us access denied, and you heard the little bell. That's because I put the \A in here. That's for alarm. So we got it wrong that time. Let's go ahead and run it one more time, and hopefully I can put in a valid code this time. And it gives us access granted. So it pretty much works like we think it should. Now let's make a couple of changes. So for our security code, we want to make sure what's entered is valid. So we're going to check to make sure if not CN, in other words, they enter something invalid, we're going to go ahead and see out some sort of error message. So in this case, we'll just say error, invalid input, and then we're going to return, instead of returning 0, which normally means the normal ending of the program, we're going to return 1. So some sort of error code. And so we can try that out. If we compile and run this, I can try something like overflowing it with too large of a number. That should be plenty. And I hit enter, and of course it's going to give me that error message we put in there, error invalid input. Okay, so that's one thing we might want to check for. The other thing we can do, I'm going to need another library here because we want to check our array to make sure we're within bounds. So I'm going to include the assert header file, and we're going to go down here, and I'm going to make a couple of assertions. Now this is not great error checking, but it's better than nothing. Okay, so I'm going to assert. Okay, and we need to check to make sure we're within the bounds of the array. So it could be too low a number, too high a number, but I'm going to assert that I is greater than or equal to 0. In other words, that's the lower bound. We can't have negative numbers as indexes for the array. And then I'm going to make one more assertion that I is less than, and we'll look up here. We could either use array size, or we can actually grab it from the size function. So we'll check the size of code and make sure that it's within bounds. Okay, and so if nothing happens, if our assertions are okay, it should just run fine. Okay, so we'll compile and run this. And we'll go ahead and put in our security code, and everything works just fine. Okay, but let's say we got this wrong. Let's say we were playing with this, and maybe I delete one of these codes. Maybe somebody left the company. We don't have that code anymore. As it goes through to check the last element, notice why I should have put array size here, because it would be dynamic. I remove that value, and it dynamically changes this value. Otherwise, I have to remember when I'm maintaining this code to go back and change that hard constant. So again, hard coding is usually a bad idea. So let's go ahead and execute this to see what kind of an error it's going to give me. And so I will put in our code. And in the process of checking it, notice the error message we get. Our assertion failed, and it tells us a line number, line 24. So it doesn't go out and check something beyond the end of the array. So this is kind of dangerous in C++. We can't access memory beyond the end of our variable. So it's just the next thing, next space out there that we're accessing. Okay. So let's fix this a little bit better. I'll put that back. And another way to demonstrate this is I could say 10 here. Well, that's wrong because that's still one past the end. So a better way to do that here is size code. So if we do this, these assertions should never happen. But we put them in here because over the years, if you're maintaining this code and other programmers are maintaining your code, there's potentials for error. So we put these asserts in here to make sure that we don't get any type of error with the size of the array or the bounds of the array being involved. So we could test the other one. We would just kind of have to force I in here to be something like -1, which would be bad in arrays, but it would test our assertion. I'm going to go ahead and assume that works. The other thing we can do is show that it's checking each code. So I'm just going to put this output statement here, and it's going to output each code in the array. And what I want to show is, we're compiling and running this, that even if I put in my code that's second in the list, it still goes through the whole array and checks everything before it approves me, okay, or gives me the access granted. That's a little bit efficient if our list got very long. So what I want to do is add something to my if statement. So I'm going to do an open brace, because now we have a block of code, right? We want more than one thing to happen if this condition is true. And so what I'm going to do is add a break statement in here. So this will break us out of the loop, and let me show you how that works. I'll compile and run this. I'll put in that code again, and what you'll find out is that break, as soon as it finds our code, it breaks out of the loop, and it actually didn't even print our code, it just prints the first one in the array because of where I put my statement. But notice it does not check the whole list. As soon as it finds the first valid code, it stops and breaks out of that. So that makes it a little bit more efficient, and later on we'll probably look at some search algorithms when searching through arrays that are probably even a little bit better than this. Okay, so that's an example with a little bit more error checking, and as I look through this, I see one other problem here. That double probably could stand to be an int, is what I meant to do at the beginning. Hopefully this was a useful example for you and helps you understand arrays a little bit better, and also validate